Many workplaces contain spaces that are considered to be confined because their configurations hinder the activities of employees who must enter into, work in, or exit from them. In many instances, employees who work in confined spaces also face increased risk of exposure to serious physical injury from hazards such as entrapment, engulfment, and hazardous atmospheric conditions. Confinement itself may pose entrapment hazards, and work in confined spaces may keep employees closer to hazards, such as machinery components, than they would be otherwise. For example, confinement, limited access, and restricted airflow can result in hazardous conditions that would not normally arise in an open workplace. The terms permit-required confined space and permit space refer to spaces that meet OSHA's definition of a confined space and contain health or safety hazards. For this reason, OSHA requires anyone to have a permit to enter these spaces. Throughout this training program, the term permit space will be used to describe a permit-required confined space. Employees have been entering and working in confined spaces for many years. Most of them return safely, but many do not. Whether you're employed in a university, chemical plant, public agency, or construction firm, the confined space hazards you face are quite similar. There isn't any room in confined space entry for risk-taking. Every job must be approached with a professional attitude and a methodical system designed to prevent situations from escalating into disaster. The National Institute for Occupational Safety and Health, or NIOSH, found in more than 50% of confined space accidents, the rescuer becomes the victim. This same scenario is repeated time and time again. A worker is overcome by an atmospheric contaminant, and the rescuer, being a concerned person, goes into the space to rescue the overcome worker, only to become a partner in death. NIOSH also found that very few organizations provided any type of written procedures or training specific to confined space entry. Rarely had the confined space been tested for atmospheric hazards prior to entry, or had any provision been made for ventilation or safe rescue. This training program is designed to provide you with safety basics involved in confined space entry. Of course, we can't cover all the hazards or safety procedures, but we will go over the most essential safety methods. No matter how you look at it, confined space entry is a complicated matter requiring specific procedures, so you must always follow policies and procedures. Let's start with the definition of a confined space. The Occupational Safety and Health Administration defines a confined space as any area which is large enough and so configured that an employee can bodily enter and perform work and has limited or restricted means for entry or exit, is not designed for continuous human occupancy. By this definition, is the sewer manhole a confined space? How about a gas tank or water utility room or a tank? Instrumentation room, wet and dry well, silo, pipeline, pressure vessel, hopper, photo developing room. If you answered yes to all these questions, you're correct. The very first and most basic safety rule is never, ever trust your senses. That's right. In confined spaces, workers will swear that they can tell when the air turns sour. Well, they're wrong. Dead wrong. There are many hazards that just can't be detected by the human nose until it's too late. Other hazards can actually play tricks on your sense of smell, lulling you into a false sense of security. Confined spaces can be categorized generally as those with open tops and with a depth that will restrict the natural movement of air, and enclosed spaces with very limited openings for entry. Any chemical laboratory, and especially a small laboratory with only one exit, can easily turn into a confined space. A permit-required confined space means a confined space that contains or has the potential to contain a hazardous atmosphere, contains a material that has the potential for engulfing an entrant, has an internal configuration such that an entrant could be trapped or asphyxiated by inwardly converging walls or by a floor which slopes downward and tapers to a smaller cross-section, or contains any other recognized serious safety or health hazard, such as noise, electricity, radiation, or moving parts of machinery. Let's take a moment to review the most common confined space atmospheric hazards. Many confined spaces may contain flammable and/or explosive gases or vapors. Often, these hazards occur naturally from decaying paint or animal material, natural gas, chemical and petroleum byproducts, illegally dumped hazardous materials, or seeping fuel. It is important to remember a couple of important points regarding flammable and/or combustible environments. Some flammable and/or combustible vapors are lighter than air and collect at the top of the space. Others, which may be heavier than air, settle at the bottom. Common flammable gases found in confined spaces may be carbon monoxide, natural gas, hydrogen sulfide, and methane, to name a few. Remember, methane, in addition to being lighter than air, may also push out oxygen from the space, causing suffocation. Methane, also known as sewer gas, is odorless, colorless, and explosive. As if oxygen deficiency and explosive gas aren't enough to worry about, in some cases, toxic vapors and gases can cause injury or death, even in low concentrations. Toxic atmospheres are generally divided into two major classes. These are irritants and asphyxiants. Not only is oxygen deficiency a concern, but in certain cases, an excess of oxygen can occur, creating a fire hazard. Generally, an oxygen-enriched environment contains at least 23.5% oxygen. In this case, a spark or other source of ignition can cause a flash fire or an explosion. However, gases that are heavier than air, butane, propane, and other hydrocarbons remain in depressions and will flow to low points where they are difficult to remove. Open-topped water tanks that appear harmless may develop toxic atmospheres such as hydrogen sulfide from the vaporization of contaminated water. Therefore, these gases, heavier than air, are a primary concern when entry into such a confined space is being planned. Irritants are gases that in low concentration may only cause an irritation to your respiratory system, such as a sore throat or coughing. High concentrations can cause serious concerns or even death. Irritant or corrosive atmospheres can be divided into primary and secondary groups. The primary irritants exert no systemic toxic effects on the entire body. Examples of primary irritants are chlorine, ozone, hydrochloric acid, hydrofluoric acid, sulfuric acid, nitrogen dioxide, ammonia, and sulfur dioxide. A secondary irritant is one that may produce systemic toxic effects in addition to surface irritation. Examples of secondary irritants include benzene, carbon tetrachloride, ethyl chloride, trichloroethane, trichloroethylene, and chloropropene. Prolonged exposure at irritant or corrosive concentrations in a confined space may produce little or no evidence of irritation. This may result in a general weakening of the defense reflexes from changes in sensitivity. The danger in this situation is that you may not be aware of any increase in your exposure to toxic substances. An asphyxiant causes an extreme decrease in the concentration of oxygen in the body, accompanied by an increase in the concentration of carbon dioxide, which leads to loss of consciousness or death. Asphyxiants can cause death by displacing or pushing out the air you need to breathe. Depending upon where you live, the air you breathe generally contains about 21% oxygen. In order to safely enter a confined space, OSHA requires that the space have a minimum of 19.5% oxygen. Levels of 14% can cause difficulty in breathing or drowsiness. 12% can create an inability to think clearly. At 10%, unconsciousness can occur, and at 8%, well, you're probably history. The most common asphyxiants are carbon monoxide, carbon dioxide, and sulfur dioxide. Be aware that any one or combination of these hazards can coexist in a confined space. Carbon monoxide irreversibly binds with the iron in hemoglobin to cause asphyxia by preventing oxygen transfer in the body. You can't see it, smell it, or taste it, but carbon monoxide can kill you. Carbon monoxide is the leading cause of accidental poisoning deaths in America. This odorless, tasteless, and colorless gas is known as the silent killer. Carbon monoxide is formed when organic compounds burn. The most common sources are motor vehicle exhaust, smoke from fires, engine fumes, and non-electric heaters. For example, in the laboratory, an inefficient burning Bunsen burner will produce carbon monoxide. It is important that the flames on Bunsen burners be adjusted by turning the collar to regulate airflow and produce typically a medium blue flame. A yellow flame indicates possible carbon monoxide emission. Believe it or not, a gas as harmless as nitrogen can be an asphyxiant under some circumstances. An example of air displacement is when liquid nitrogen is used in a laboratory. Liquid nitrogen is often used in diffusion pumps on high-resolution mass spectrometers and in Fourier transform nuclear magnetic resonance instruments. If the laboratory is not properly ventilated, the nitrogen from the liquid nitrogen reservoirs can displace oxygen and produce an oxygen-deficient atmosphere. Another potential oxygen-deficient atmosphere can occur when dry ice is used as a coolant. Dry ice is solid carbon dioxide at the temperature of minus 110 degrees Fahrenheit. Since dry ice vaporizes and forms a gas that is heavier than air, it will settle to the floor of a laboratory. If the laboratory is not properly ventilated, a potentially hazardous decrease in ambient oxygen concentration can occur. The OSHA standard requires that every confined space site must be monitored by a trained employee designated as a competent person. A competent person is defined as one who is capable of identifying existing and potential hazards in the surroundings or working conditions, which are unsanitary, hazardous, or dangerous, and has authorization to take prompt corrective action to eliminate the hazards. A competent person must have knowledge, skill, training, education, expertise, and authority. The competent person's sole job is to supervise the safety activities of the task, monitor the atmosphere where confined space hazards may exist, and assure that only trained employees are assigned to the job. Let's now talk about the proper techniques involved with confined space entry. First, acquire permission. Complete the necessary permits or forms, and arrange for all the necessary equipment to be on site. The atmosphere in all permit-required confined space atmospheres shall be tested for oxygen concentration, combustible gases, and any known or suspected toxic substances prior to entry. A properly calibrated direct reading gas monitor will be used. Direct reading gas detector tubes or other acceptable means may also be used to test potentially toxic atmospheres. Each atmospheric testing instrument will be field checked immediately prior to use to ensure that it is operating properly. Atmosphere testing will be performed by a person qualified by the safety department. Initial air sampling will be conducted from outside the confined space and will be performed when possible excursions may occur. The atmosphere will be tested in the following order: oxygen concentration, combustible gases, and toxic materials. Results will be written on the entry permit. Atmospheric conditions will be considered unacceptable if oxygen levels are less than 19.5% or greater than 23.5% by volume, or if a combustible gas is present at greater than 10% of its lower explosive limit. They will also be unacceptable if a toxic substance exceeds an OSHA or American Conference of Governmental Industrial Hygienists limit, where exposure could result in death, acute illness, or impairment of ability to self-rescue. In addition, atmospheric conditions will be considered unacceptable if an airborne combustible dust obscures vision to 5 feet or less, or if any atmospheric condition recognized as immediately dangerous to life or health is present. Unacceptable levels may be indicated on a scale or by a visual alarm and must be indicated by an audible alarm. Confined space emergencies are no place for single-handed heroics. More than 50% of confined space deaths involve potential rescuers. Should an emergency arise, the observer will immediately summon the emergency standby to call for assistance before any attempt to enter and make a rescue. You should always have all emergency numbers handy for use. If your organization uses employees to make a confined space rescue, each employee must be provided with and trained in rescue procedures, personal protective equipment, and equipment required to make a rescue. A fully completed entry permit will be prepared by a competent person or the qualified person prior to entry into a permit-required confined space. This person will be in charge of the entry. The entry permit documents acceptable entry conditions and verifies that the space is safe for anyone to enter. Required permit information includes location of the permit space, purpose of entry date and the time employees will enter, authorized entrance names, authorized attendants names, entry supervisor's name and signature, hazards in the space, and how hazards will be controlled so that the space is safe to enter. In addition, permit information will include acceptable entry conditions and testing data and testers' initials that certify the space is safe to enter. Further information will include the names of emergency responders and instructions for contacting them, and communication procedures used by entrants and attendants. There should always be at least one person outside the permit space into which entry is authorized for the duration of entry operations. You should know who the designated persons are and who has active roles. For example, authorized entrants, attendants, entry supervisors, or persons who test or monitor the atmosphere in a permit space in entry operations. Duties of each person should be identified, and each person should have the required training. You should know procedures for summoning rescue and emergency services, for rescuing entrants from permit spaces, for providing necessary emergency services to rescued employees, and for preventing unauthorized personnel from attempting a rescue. You should also know your system for the preparation, issuance, use, and cancellation of required entry permits. All personnel involved in confined space work shall receive appropriate training in hazard recognition, personal protective equipment, safety equipment, communications equipment, procedures for calling rescue services, and proper use of rescue equipment. Training shall be performed before the employee is assigned duties in permit-required confined spaces. Retraining will be performed at least annually. Training records will be maintained by the safety coordinator. These records shall include the dates of the training program, the instructors of the training program, a copy of the written material presented, and the names of the employees to whom the training was given. Testing for safe environment makes sense. The use of emergency egress equipment also makes sense. Training, personal protective equipment, permits, written procedures, and other related requirements all lead to a safer workplace for you. In this program, we have described procedures to help protect you from hazards associated with confined spaces. There are a variety of procedures and protocols to follow when working with confined spaces in your laboratory. We have discussed who to contact, hazards, flammability, personal protective equipment, general precautions, and training. We hope that you can use this information to stay safe and healthy in your learning environment. Remember, confined space work can be extremely hazardous, and although we can't provide all the necessary training required for safe work in confined spaces, we hope this program has made you more aware of all the hazards involved. If you have any questions, contact your safety department.